teach, the speech processing class, I spend some time talking about speech, how it's produced, and the acoustic properties, just because I feel if you're going to be exposed to this area, you should know something about speech. I continually am amazed. There isn't enough of that, unfortunately. We have entered an era where you can just treat speech as a sequence of observations, and then build your model on top of that. So you don't need to know much about speech. I feel there is benefit to that, but I don't know if that's a losing battle or not, actually. So it's kind of sad. I think it's useful to know something about speech properties.
See, it's all very well for them to build technologies which will make sense and so on and so forth. But I think the fact that pedagogy is taking a backseat, it's a very serious problem for the science to progress further, irrespective of whatever we do. If tomorrow some other technology comes, we will not even be in a position to adapt to that new technology because you don't know the science. If you find that people who went from classical machine learning to deep learning was very easy because they knew the science. Now you create a bunch of engineers who only know deep learning and nothing more than that.
What we do is we teach them about phonetics and phonology. I don't go into, huge amounts of detail. And then they just get to do some exercises with Prot. And they learn a lot about what to do and what not to do. And then they start using that in their homeworks. And they build their models on that. And of course, they want to just build deep learning models if they are computer science. I got some students from linguistics, so it just doesn't, But anyway, I'll send you my syllabus and you'll see the kind of things that we are trying to, because to get them onboarded, they really have to know a lot about linguistics, probably more than I can teach them, but also a lot about phonology and phonetics. And everything there is to know, hopefully, well, at least a lot of what there is to know about speech production.
The thing about the student training, I find that's really important and fascinating area.
Yeah, so let's stick with that for a few minutes.
Yeah. I mean, you may recall that was it oh golly, I've forgotten which was it. Shanghai, or anyway, was it the Shanghai Interspeech? So I proposed a tutorial called Speech 101. Which was, and the subtitle was what everybody working on spoken language processing should know about spoken language.
Okay, I missed the Shanghai Interspeech, but I'll go back.
So it was one of the tutorials, and when I submitted it, I thought, well, this is going to be rejected outright because it's, it's not in the normal vein of tutorials, which is usually the very latest thing, and they're very popular. Not only was it accepted, but there were a phenomenal number of people signed up for it, which was incredibly confirming for me. Nice. People were obviously very, very interested, and also I'm kind of thinking, well, don't you know this already? I mean, you're in the speech field, don't you know all this? And so it was confirming, and I thought, okay, this is needed. By the way, they're now on YouTube. I uploaded them last week.
Okay,
there's 3 hours.
At least good to know the history, where we came from, how did we evolve? I think that's one thing that's missing. I think many people, just know what's there without knowing how we got there. And I think that's dangerous because if things change again, they'll have to, again, redo everything without, but if they had a general background knowledge, the recycling and and changing wouldn't be as dramatic because all of these are similar, just to have different hats and different names. But a lot, like, you know, whether you do call it adaptation, you call it transfer learning, or you know, it's helpful to know what has happened before and how we got here, because inevitably we'll go back to some of these techniques. So yes, I would be in support of a broader education. In general, you know, things like statistics and optimization and just the basics. And then, of course, you know, things related to neural networks. But one thing I do find, maybe we're doing a little bit more than before, is a connection with vision and image processing. And I think so for a while, you know, speech was really ahead, right? Speech recognition was always ahead, but I think computer vision now is also having some really interesting techniques and algorithms that we can benefit from. Same thing with NLP. So I think, so maybe the biggest change has been more on, you know, exposure to computer vision, exposure to NLP, more formal exposure, because I think those fields, I think they are introducing very nice and interesting techniques, which could be beneficial. So that probably is the biggest change from 10 years ago.
Random processing, you know, statistical signal processing. You definitely want them to know. They definitely want them to have a really good understanding of digital signal processing.
Yeah.
Sort of the base, you know,
Absolutely. Yeah.
what's now the basics, but before it was kind of advanced. But you know, and so they know it, so they can look at signals. They know how to relate what they see in frequency with what they see in time, and they know why the signal looks the way it looks. I think as much of that as they know is helpful. I won't say they have to have complete knowledge of that, because that's something they can gain, you know, as they are working.
Right.
But and you want them to know, so all of the basics they need to know, you know, and then they don't have to know deep learning coming in, because that's something they can pick up. But I don't want to lose the speech acoustics and the speech science part of it, because I think that that's critical to really understand what's going on physiologically and perception was important. I think speech perception is very important because the signal is so complicated. But knowing what are the things that you really have to pay attention to and the others that you don't. So you need to understand, you know, masking and what the ear is doing and what the brain is doing, and, you know, as much of that as possible too. I think neuroscience is a very important
There you go. Yeah.
field now. And I think that understanding that, and maybe you're not going to understand it as well as a neuroscientist, but you want to be able to have conversations and be able to learn from them, because I think there's a lot there that you can bring to bear. Oh, definitely.
Yeah.
Definitely. That's a huge part if you're going to use AI,
Right.
is that students need to be informed about how to use AI, how to think about the problem well before they even start collecting trainer data, so that they try to make sure that they remove any bias that they think could be there, that is removed.
I'm just teaching a conversational AI course this term, and I did talk about a little bit about how to read spectrograms. You know, in fact, one thing I want to bring out is the tools change, but speech doesn't. You know, human speech is human speech, so the tools change, and the tools change quickly. And maybe now, you know, it's all kinds of fancy schmancy deep neural networks. Maybe in about a few years or in a decade, then we have some other thing. I don't know. Who would know?
Yeah.
But speech is speech. Until we actually solve the problem, we need all kinds of tools. Yeah.
Just maybe because I'm old school, but I really like looking at the signal, listening to the signal. And so when I see things that strike me as weird, how could the system envision that? I go and I look at the signal and I listen to it and I believe my eyes. And I don't know. I mean, I guess if you're an engineer and you're a machine learning guy and you're only interested in machine learning, it doesn't really matter what you apply it to. You're not going to look at the signal. But I find it too bad for people to call themselves speech scientists if they don't look at the signal.
I have something else to say about data sets that I worry about, right? So in the old days, we used to have sort of like DARPA evaluations where you'd have a new unseen data set. And also we didn't have so much compute, so you probably couldn't really do thousands of experiments. But nowadays, certainly on some data sets, people really have done huge numbers of experiments on the test data, and you're really not quite sure what these numbers mean sometimes. So that's sometimes something I worry about. I guess about people, the way people go about doing experiments and exploring things. And if you're too much focused on getting a slightly better number, you might not be so worried about, well, actually, is this generic? Is this going to apply? Would I really expect if I had some new data of a similar sort to work? And so the fact that we don't have so much new data of various sorts, I think is a bit of a problem sometimes. What people want from, say, reading a paper, that they want to have a good take-home message. They don't really care what the number is, whether that number is slightly better than that number. They want to learn something which they can apply different contexts and really understand something better, I suppose. And it's very easy to get obsessed by saying, oh, well, this is a table of numbers and I want my number to be slightly better than the other numbers. Of course, that perhaps helps, but and it's a nice thing, but you're really wondering whether it applies to things beyond that data set.